All right, now this question, we've been given an equation and we're going to be asked to find the center and the radius. All right, so it's just a matter of reading it off the graph. So here is our h value, here is our k value. We just have to remember that there's already a negative in there, so we read the opposite of it. So h equals +1, k equals +2. This is the r value, and we have to read that as a square root. So r equals the square root of 4, which is 2. All right, now you might think to yourself, oh, we know that square root of 4 should have two solutions, which you're right, it does. It has +2 and -2. But think about it in terms of a practical example. What would a radius of -2 look like? We don't need to know direction because that's told to us by h and k. So this solution here we can disregard and just read basically the absolute value of the square root of 4, which is 2. All we need to know is the length. So it's 2 units long, whether it's negative or positive makes no difference. All right, so we can say safely that the radius is 2 units. Probably helpful to get into practice of writing units because you are talking about length. The center. Now the center, we can read here it's been moved 1 unit right and 2 units up. So the center is now at 1, 2. All right, so 1 unit right, 2 units up. And the reason they were the opposite from the brackets is because this negative sign is embedded into the formula. So you have to read the opposite. All right, in this example, we're going to be asked to sketch a circle. And it might seem a little bit overwhelming at the start, but you just have to trust to your skills at this point. So first of all, let's identify the h and k values. So we've got h here, we've got k here, and we've also got radius there. All right, so h equals -1, being the opposite of what's written in the brackets. K also equals -4, being the opposite of what's written in the brackets. And the radius equals the square root of 9, which is 3 units. All right. Now, as before, I'm going to do a quick sketch of the information I've got from this, and before I solve for any of the x or y intercepts, just to make sure that I have a pretty good idea of what's going on. So the center is at -1, so -1 and then 4 down, 2, 3, 4. So it's about there. And the radius is 3 units. So the circle will touch this point here and be sort of like that. It's 3 units in any direction, like so. My circle is not great, but we can get away with that. All right, so now it looks like it goes through the x-axis twice at this point here and this point here. It looks like it doesn't go through, sorry, it goes through the y-axis twice. It doesn't look like it goes through the x-axis because it doesn't touch at all. So let's do some calculations to find out if we're right. So to solve for the y-intercepts, we solve for when x equals 0. So we'll go 0 plus 1 squared plus y plus 4 squared equals 9. Simplify this bracket here. 1 squared plus y plus 4 squared equals 9. Don't be tempted to expand out the y plus 4 brackets because you don't need to. 1 squared is 1. Equals 9. Move the 1 across, end up with y plus 4 squared equals 8. Square root both sides, end up with y plus 4 equals plus or minus √2. Now it's interesting here because plus or minus, at this point, it is useful because it does show us that there's going to be 2 different intercepts for the y-axis, which is one up the top and one down the bottom. All right, so keep going. Minus the 4 from both sides, y equals -4 plus or minus √2. All right, so here's something else that's interesting. You might notice that -4 seems to be that center point where you're adding √2 and subtracting √2. And if you look back at our center of the circle, you'll see that it's also at -4. So this is a clue that we've done the right thing. To find the y-intercepts, we find the center and then go up a certain distance and down the same distance. All right, so circles have an amount of symmetry because of the way they're designed. Okay, so we can label this point here as -4, what would that be? Plus √2 to bring it up, and this point here would be -4 minus √2 to take it away from the origin. All right, so that's those points. Now, just to confirm in our minds, the graph doesn't look like it has x-intercepts, but we'll confirm it by doing the calculation. we'll try and solve for when y equals 0 and see what happens. So we're going to have 0 plus 4 squared equals 9. We'll have x plus 1 squared plus 4 squared equals 9. We're going to have x plus 1 squared plus 16 equals 9. And then we're going to move the 16 across, and you'll find out why it doesn't work. 9 minus 16 is negative 7. So at this point here, if I get to this point and think I can go one step further, I'll square root both sides. That will give me x plus 1 by itself, but it will also give me this, which is the point where we say to ourselves, that is not possible, so therefore there must be no x-intercepts. All right? So our initial assumption was correct. We've got no x-intercepts there. We've got two y's, but no x's. So I'm going to give another quick sketch. I'll use a different scale. We've got our center here, which is at, what was it? -1, -4. We've got our y-intercept here, which was at 0, -4 plus root 2. We've got our other one down here, which was at 0, -4 minus root 2. And then we can plug in, or just roughly join these up with a bit of an arc and continue it around the center of the circle there. And there you have your circle, all right? You don't have, I'm not expecting you to draw these curves super accurately. It's nice to have it roughly the right shape, but the most important thing is you've labeled your points, you've calculated the right points, and you've found all the important information in the graph. All right, and even if you suspect there are no intercepts of one kind, it's important to try and get there to prove it, because your assumption could be off in the first place. All right, so I hope that makes sense. All right, in keeping with the inadequacies of general form for most different types of equations, you're going to hate this one. All right, so a circle's general form is looking like this: x squared plus y squared minus 2hx minus 2ky plus c equals 0. Now, there is no good information you can read directly from this at all. And the way to read any of the information out of it is you have to actually group your terms, group your terms with the same variable and complete the square for both of them, because that will put it back into the form of r squared. All right, so this is just ridiculous. I'll give you one example, and the good news is I've not seen this pop up on an exam at all. Not saying it can't, but I've not seen it happen. So here is an example: x squared plus y squared minus 6x plus 4y minus 12 equals 0. So first of all, we'll group terms with the same variable. I'll leave a space there because we're going to complete the square. Y squared plus 4y, leave a space, minus 12 equals 0. All right, so we'll complete the square. What's half of 6? Negative 3, negative 6. Square it, 9. So 9 is what's going to get written in here, plus 9. What's half of 4? 2. Square it, 4. So 4 is going to get written in here. Now, you remember in completing the square, you also have, when you add these in, you have to subtract them out afterwards. So out here, you're going to have minus 9, minus 4, following the minus 12. So it's going to look something like this. The next step is to factorize these now perfect squares. So it's going to be minus 3 squared plus y plus 2 squared minus 12 minus 9 minus 4 equals 0. And you can see this is now starting to take the shape or the form that we recognize more completely. Squared minus 25, which is hopefully a nice square number. And the last step is to move that 25 to the other side of the equal sign so that you can actually read the information out of it. So now it's h, k, and r, or r squared, sorry. So h equals 3, k equals -2, and r equals 5. All right, so we can translate that as being the center is at 3, -2, and the radius is 5. And if we were asked to sketch that, we would also go through and find the intercepts. But this question just asked us to find that. If you wanted to do a quick sketch, you could go 3 -2 is somewhere there, and then the intercepts there, there, join them up. Hey presto. Again, reiterating, general form, you must group the terms with the same variable, so x's and y's. You need to then complete the square for both of them to get this form that we're starting to do. Don't forget to subtract out the numbers that you add in, then rearrange so that it becomes the part of the form you're looking for.